Hot weather and fair skies today. There's the remains of my tomatoes. Something really got to them. The only thing really doing good is the squash. Figured I'd show you a little bit of my garden there. My failed attempt at a garden. It's been a while since I've actually done any gardening, and the bugs got to it, black aphids and a couple caterpillars, and that just kind of ruined it, but maybe I'll get some of that squash. I've got good news for this webcast. We've got changes coming up. We're breaking the stagnant pattern, and I've got the SPC map up. Anyway, I appreciate you tuning in, and I'm probably have to apologize for last night. I didn't really totally feel I was on top of my game when I was doing the live stream. Yesterday, I probably had a bit of a virus or something like that, but I'm feeling better today, and hopefully that'll be it for whatever's going around. So what do we have here? Lots of hundreds. I'm using the SPC mesoscale analysis here, and I can circle the hundreds to show you how this area has bloomed. So we've really expanded that area of hot conditions, and that's underneath that upper level high. We've got subsidence and adiabatic warming underneath that upper level high. And we got just enough subsidence to where it kept things pretty shut down across Texas. Not much in the way of any clouds. They did try to get going earlier. Where's my map here? Yeah, this is earlier today from the polar orbiters. You can see one little area of towering cumulus there near Wichita Falls, and this is spectacular. This is almost like looking at it out of an airplane window. You can see this anvil just starting to form, only about 5, 6, 7 miles wide. Another anvil starting to form here, but what did these in was entrainment of dry air into the updrafts. So that kind of shut down a lot of this stuff pretty early. The better activity was out to the east over Louisiana, Arkansas. So why are they getting all that? And we're getting nothing but clear skies here. Well, I've mentioned the upper level high. But yeah, it's actually on the surface chart, not on the sounding. Let me show this to you. Take a look at the dew points. Do you see a difference in dew points between like Dallas and Louisiana? They are much warmer, or the moisture is much more rich as you go east. These are some high levels, 79, 76, compared with 66 here. And there's a rule of thumb that every trying to think how to phrase this. I don't want to get this mixed up. A 1 degree increase in dew point is thermally equivalent to a 4 degree increase in temperature. So here we've got a 10 degrees Celsius dew point change, or Fahrenheit change. That's kind of like throwing on another 40 degrees of warmth. So, yeah, that's definitely going to favor storms out east. And on the sounding, we will see those parcels. The temperature line is going to be way over here like this. See, am I lifting from 95? Let me try to do this correctly. I'm kind of rushing through here. But if we take that mid-70s dew points, that's going to be about right here, about 24 Celsius. So we lift that up, and yeah, you can see we've broken the cap right there. Some pretty impressive cape. This is getting up to about 1,500 to maybe 2,000 cape. But a lot of dry air right above the surface. This is drier than what we tend to see in the springtime around here. Just out of curiosity, I was looking at that air mass out over Louisiana. I was kind of wondering where they're getting these high dew points from. Because you can see there's not much of any flow off the Gulf. The flow is kind of chaotic across Louisiana. I ran the high split trajectory model. This is on, I don't know if you can see that URL there. It said ARL, try that again, arl.noaa.gov. And they've got this neat little trajectory model, and it's fun to play around with this and kind of get used to setting up, cases. And in this case, I ran a backwards trajectory to find out where the low-level air is coming from across Louisiana. And this is the map that I got here. So this ends at 0Z. Actually, I think we are looking at some old data here. This is for the 9th. Okay, yeah, I didn't catch that earlier. But anyway, this shows on this particular case, I built up 3 parcels, one at 30 meters above the ground, another 500, another 1,000, and I ran those backwards over 72 hours, and I can see that see, this is going to be Monday. Man, this is pretty old. So Monday evening, the parcels that are over Louisiana probably came from the Corn Belt, Oklahoma, and so on. I don't know how accurate this model is in convective regimes like this, because if you have a parcel that gets ingested into a cumulus cloud, gets lofted up a couple of kilometers, that can completely change the trajectories. So there's a lot of chaotic motion in there. That's where you get the butterfly effect going on, and that's less of a factor when we're in a stratiform type situation. So this is pretty cool. This particular website, I don't know if I showed this to you, but this is from NASA. This is worldview.earthdata.nasa.gov, and this allows you to view the polar orbiters. Excuse me. We are back. I want to make sure we don't get the answer machine going off. I guess that'll be our first blooper there of this segment here. But anyway, this is pretty cool. The problem with these polar orbiter satellites is it takes about an hour or two for the data to be post-processed and mapped onto these geographical overlays. So it's not very good for forecasting, but if you're looking at a case study, if you went out chasing, this is excellent for finding boundaries, because this is quarter-kilometer resolution visible imagery. With GOES, the best you can get is 1 kilometer. That's going to increase next year to half kilometer, so that's going to be pretty cool. But these orbiters are 1/4 kilometer. The main downside is you only get the images once per day. There's a pass at nighttime too, but we have 3 satellites, and this kind of comes in between the 10 o'clock a.m. and the 1 p.m. time range. So this is good for before convection gets going. You can check this out and look back on a case study, and this will give you more information than the GOES products. But yeah, there's some pretty good moisture out there in the hill country. Got some deeper towers, so probably a little bit of a feed coming up the Rio Grande there. And there's Old Faithful there west of Del Rio. Okay, let's move on here. Okay, we looked at the surface data. I'll probably go into more detail on the mesoscale analysis, SPC, when we actually have like storms moving into Texas proper. I'll probably do a longer webcast, and we'll go into more of these parameters. This is going to be probably too involved to get into tonight, but let's see here. Let's look at that forecast and see what's coming up. Okay, so I'm running this back to 18Z, and we've got a polar front jet across the Great Plains. So this time of year, fast flow aloft is everything. This is what's going to happen. Yeah, keep an eye on this over the next few days, and you'll see how this kind of works southward towards Kansas and Oklahoma. So we're starting to crank up the upper level flow. This gets the bulk shears up higher. So we're going to start seeing some chances of thunderstorms and showers starting this weekend and probably into next week. And you can see as we go up through the 16th and 17th, we're bringing in this belt of 30, 40 knot winds. So that's going to keep the rain chances up for a while. And that high pressure backs off into Mexico. So we're probably going to be looking at a cooler pattern too, which I'm grateful for. My air conditioner has been running overtime with this 100-degree heat. And that, northwesterly flow, this is way out there. This is 300 hours, August 25th. But if this pans out, we would start seeing northwesterly flow storms coming into Texas and Oklahoma. That would be like a lot of nocturnal stuff. But this is a ways out, so. But that's an interesting pattern. When we see that during the wintertime, that's what we get with these Arctic outbreaks. You get these strong jets coming up into the Arctic Ocean. They come straight down through the Northwest Territories and into central Canada, and that drives the Polar Express all the way down south into Texas. So that's kind of an unusual pattern for this time of year. We'll see if that pans out. So I think we're finally getting out of this slump and into some interesting weather, and we'll probably run some longer segments here. All right, I think that's about all I've got for today. I hope we'll see you tomorrow, and have a good one. Thanks.